Hello, myself Moheshan Gowda. I'm from Sri Venkateswara College of Engineering. I'm currently studying electronics and communications, and today we are gonna talk about environmental issues with adaptation of EV vehicles. As electronic vehicles gain popularity, it's important to consider the environmental impact of their widespread adaptation. From manufacturing to charging, EVs bring both benefits and challenges to sustainability efforts. Greenhouse gas emissions and EV manufacturing. Resource-intensive production. The manufacturing of electric vehicles requires significant energy and resources, including mining of rare earth minerals, battery production, and vehicle assembly. This creates a carbon footprint during the early stages of an EV's life. Emissions from electricity generation. Although EVs produce zero direct emissions while driving, the electricity used to charge them may come from fossil fuel power plants, indirectly contributing to greenhouse gas emissions depending on the regional energy mix. Opportunity for improvement. As renewable energy sources become more widespread and battery technology continues to advance, the environmental impact of EV manufacturing and charging can be significantly reduced, making them a more sustainable transportation option. Electricity grid capacity and renewable energy sources. As EV adoption grows, the demand on the electrical grid is increasing significantly. Power grids must have the capacity to handle the surge in electricity consumption from EV charging, while also incorporating more renewable energy sources to reduce overall emissions. Grid modernization efforts to expand transmission and distribution capacity are crucial to support the higher energy demands of widespread EV charging. Integrating a diverse mix of renewable energy sources such as solar, wind, and hydroelectric power can help offset the carbon footprint of EV charging loads. Smart charging technologies and time-of-use electricity rates can incentivize EV owners to charge during off-peak hours when grid capacity is higher and renewable energy production is at its peak. Earth mineral mining and environmental impact. The mining of rare earth mineral essential for EV production can have significant environmental consequences. Extraction processes often involve toxic chemicals and disrupt fragile ecosystems, leading to water pollution, soil degradation, and air quality issues. Sustainable sourcing and recycling of these critical minerals is crucial for mitigate the environmental footprint of the EV industry and ensure a more responsible supply chain. Battery production and disposal challenges. The production of lithium-ion batteries for electrical vehicles require the mining and processing of rare earth minerals, which can have significant environmental impacts. Proper disposal and recycling of spent batteries is also a growing concern as EV adoption increases. Improper disposal of batteries can lead to release of toxic materials into the environment, highlighting the need for robust recycling programs and sustainable battery production methods. Charging infrastructure and energy consumption. Charging stations. Widespread deployment of public charging stations is crucial to facilitate EV adoption. This infrastructure must be reliable, accessible, and powered by renewable energy sources. Grid capacity. Increased electricity demand from EV charging could strain grid capacity. Upgrading grid infrastructure and integrating renewable energy sources is necessary to meet growing EV charging needs. Home charging. Enabling convenient home charging is a key factor in EV adoption. Policies and incentives to support residential charging installations can make EVs a more practical option for consumers. Life cycle analysis of EVs versus traditional vehicles. Manufacturing impacts. EV manufacture requires more energy and resources upfront due to battery production, but they have lower emission during operation. Energy sources. The environmental impact of EVs depend greatly on the electricity grid and renewable energy mix used to charge them. End of life disposal. Recycling and proper disposal of EV batteries is crucial to minimize waste and environmental harm. Policies and regulatory considerations for EV adoption. Government incentives. Many countries offer purchase rebates, tax credits, and other financial incentives to encourage EV adoption. These help offset the higher upfront cost of EVs. Emissions regulations. Stricter emission standards and zero emission vehicle mandate are driving automakers to accelerate their EV development and sales. This regulatory pressure is a key factor enabling wider EV adoption. Infrastructure investment. Governments are investing in public charging networks, grid modernization, and renewable energy sources to support the growing EV ecosystem. This infrastructure enables broader EV accessibility. Policy coordination. Alignment between nation, state, and local policies is crucial to provide a cohesive framework for EV adoption. Coordinate policies can maximum the impact of EV intensities and regulations. Consumer education and changing driving behaviors. Educating consumers about the environmental benefits and practical consideration of electric vehicles is crucial for driving widespread adoption. This includes highlighting the reduced carbon footprint, lower fuel and maintenance costs, and growing charging infrastructure. Changing driving behaviors, such as optimizing charging schedules and driving habits, can further enhance the environmental impact of EVs. Consumers must be empowered with knowledge and tools to make informed decisions and adopt more sustainable driving practices. Conclusion and future outlook for sustainable EV solutions. Renewable energy, powering EVs with clean renewable sources. Recycling, reusing EV batteries and material. Efficiency, improving the energy efficiency of EV manufacturing. As we look to the future, the key to sustainable EV solutions lies in the continued development and integration of renewable energy sources, innovative recycling programs, and enhanced manufacturing efficiency. By addressing the current environment challenges, we can realize the full potential of electric vehicles and pave the way for a greener, cleaner transportation future.